Okay, so that word at the very top that starts with a T, how do you say that? Trigonometric. Trigonometry, yes, but this is trigonometric ratios, and I'm going to show you what those are. The first thing I want to look at is let's break down the word trigonometry. Trig means triangle. Metry means measure. So literally, trigonometry is triangle measurements. Okay, that's what it is. It's triangle measurements. There's lots of different kinds. We can do sides. We can do angles. Okay, there's lots of different ways that we can find them. What did we just get done doing? Pythagorean theorem. We were solving for triangle sides. So that's one of the many methods that we can use. Okay, the first type of ratio, there are three. Okay, there are three. The first type in a right angle is called sine. S-I-N-E. Sine. Okay, we abbreviate it as S-I-N. A lot of people would say sin. Okay, but it's sine. It's for sine. Yeah, there's buttons on your calculator. We'll get there eventually. Okay, but we call that the sine. Everybody say sine. Sine. All right. The next type is cosine. Okay, we abbreviate it C-O-S. Okay, we abbreviate it C-O-S for cosine. And then the third type is the tangent, and we abbreviate that as tan, T-A-N. So again, these have to be in a right triangle. Okay, I really want you to note that these have to be in a right triangle. You cannot use these if you don't have a right triangle. Okay, it has to have that 90-degree angle in it. We doing okay so far? Make sense? Yeah. Okay. So our next part here, okay, in order to find the sine, cosine, or tangent of an angle, you need to understand how the sides of the triangle are related to the angle. So how do we use sine, cosine, and tangent? Okay, the sides of your triangle can be opposite the angle. They can be adjacent to the angle. Does anybody know what adjacent means? Right next to. Yes. Okay, so you can put next to there. So adjacent means next to, or they could be the hypotenuse. So every time that we work with a triangle, we will label its sides based on the angle that we're talking about with opposite, adjacent, and hypotenuse. Okay, and we'll go through that. Don't be overwhelmed yet. Okay. All right, I think that's all for that slide. Do we have any questions before I move on? All right, cool. All right, let's talk about how to relate these. Okay, it says for the following triangle, label the sides as they relate to the given angle theta. Okay, theta is a Greek letter. It looks like this. So when we look at the angle, we want to determine which side is opposite of that angle. Okay, I'm going to label these X, Y, and Z. Okay, which side is opposite theta? X. Okay, now, it is the only side that does not touch that angle. Do you agree with me? Yeah. Okay, so the opposite side is always straight across from the angle, and it will never touch the angle. Okay, so you can just put an O there for opposite. I'm going to put a box around mine so I don't get confused between my X, my Y, my Z, and then my so that one is opposite. What about Y? Y is adjacent. Okay, now you have the option of hypotenuse. Here's where a lot of people get tripped up. They'll look at theta and they'll look at Z and they'll say, well, that's right next to it as well. That's adjacent. But hypotenuse will always trump adjacent. Does that make sense? Yeah. So if it's the hypotenuse, you label it the hypotenuse. You don't label it adjacent. So that leaves the other side, to be adjacent. Okay, I want you to see if you can label this triangle. So again, you're using theta. So see if you can do that second triangle. You're using theta. Do you agree? We good on that? Okay, cool. Now, how do we know which side's the hypotenuse?
Because it's the opposite of the right angle.
Opposite of the right angle. Okay. So what I would probably do is I would label the hypotenuse first. That way it gets out of your way and you're not confused which one's adjacent, which one's hypotenuse. Because they won't always be like this where the right angle's at the bottom. Sometimes it may look like this, you know, where the right angle's here. So it might help you to label that hypotenuse. Yes?
Is the adjacent one always opposite from the hypotenuse?
Yeah, but I mean, you can think about like the opposite is too. You know what I mean? Like they're always kind of like that. I just always just do the hypotenuse first, and the other one will be adjacent. I think that'll make it easier for you. Okay, so this is supposed to be covered. Hold on a second. That's overwhelming. Okay. Okay. You need to remember this. SOHCAHTOA. Okay, it should be there on your page. Do you see it? Okay, we say SOHCAHTOA. I'm going to say SOHCAHTOA. Do you see how I'm getting SOHCAHTOA? Because it's SOHCAHTOA. SOHCAHTOA. Okay. So this is like, I remember this from the first day that I ever learned it, and I will never forget it because it is literally a cheat sheet to being able to do trigonometry. Okay, it makes it so easy. SOHCAHTOA. Okay, so the S. Let's go this way. Okay, the S stands for sine. Okay, the S stands for sine. What can you guess the O and the H stand for? Opposite and hypotenuse. Okay, so the sine of an angle is equal to the opposite side over the hypotenuse. We tracking on that? Okay, now before I go to the next one, what do you think cosine is? Look at that. Adjacent over hypotenuse. You seen the pattern?
Yeah.
You seen the pattern? Okay, adjacent over hypotenuse. Okay, so then that means tangent is opposite over adjacent. Okay, I'm going to show you another way of writing it. Some people will be totally fine just writing it like this. That's how I like it. That's how my brain works. Some people need to see it like this, like I'm going to write it now. Okay, you can do it like this. Oops. Just like that. So you still see the SOHCAHTOA there, but it gives you the fraction. You see the difference? You kind of see what I'm saying there? So if you really like to write SOHCAHTOA like that, that's okay. Okay, if that helps you kind of remember the fraction, that's fine. Either way, SOHCAHTOA is going to help you. You get it? Anybody else confused on where we're getting our letters, anything? I want to make sure we get it. Okay. All right, questions before we move on? This is my favorite thing to teach. I miss geometry because of this. I used to teach geometry. Okay. So it says, what is the sine of z in question 1? What is the sine of z? So here's the first thing you need to do. Because look at this triangle. You have 3 angles. There's a lot of numbers going on. Don't get confused. Okay? Z is right here. So whichever angle you're looking at, I want you to just draw the little angle symbol there. Okay? Draw the angle symbol. That'll note to your brain, okay, this is the angle that we're working on. Then you want to label the sides based on opposite, adjacent, hypotenuse. So which side is opposite angle Z? 21. Okay, which side is the hypotenuse? Okay, and that leaves adjacent here. If we want the sine of Z, okay, sine is what fraction? Okay, opposite over hypotenuse. So opposite is what number? 21. Hypotenuse is? Beautiful. That's not hard, is it? Okay. But if you didn't have SOHCAHTOA, would that be hard? Yes. Okay. So that's why I say remember SOHCAHTOA. All right. Example 2. Find the cosine of A. Okay. So A, go ahead and mark that angle. label your sides O, A, and H. Okay, so cosine of A is what over what? 30 over 34. Okay, now we're going to have to simplify these fractions. Does anybody know how to easily simplify a fraction in their calculator? Anybody remember how to do that? Math, enter, enter. Okay, so I'll do it up here on the board. If you can do it in your head, that's okay too. You can do it like that, but there's going to be some that might be a little bit tough. Maybe. All right, it should be 15 over 17 when it simplifies. Okay, anybody else need help with their buttons? Okay, so you just do 30 divided by 34, press enter, math, enter, enter. It should change to your fraction. Okay, your solutions on your practice problems will be simplified. That's why I'm going to show you these. I personally don't necessarily care about simplifying, but that's how the answers are. Well, the reason being is because this is literally the first step in solving for the angle. Because there's a process that we use to actually get the angle measurement, the degrees. And I'm going to show you guys that on Monday. So, okay. Example 3. What is the tangent of C? So tangent of angle C. So you're going to label angle C. Okay, label your sides. Don't get fooled on this one. Don't get fooled on this one. Make sure you know that the hypotenuse is across from that 90-degree angle. All right, so tangent of C is opposite over adjacent. 14 over 48.
That's what I got.
Which would be? Yep. Good. Okay, I want you to try example 4 on your own. I'm sorry, examples 4, 5, and 6 on your own. Example 7, I would like to do with you if you'd be so kind as to pause before you do that. Okay? So 4, 5, and 6 only at the top. And then I'll start and do number 7. Get right SOHCAHTOA at the top of that page if you need to help you. Okay, we ready for answers? Okay, example 4, cosine of C is 3 over 5. Example 5, tangent of alpha is 8 over 15. And then example 6, sine of A is 8 over 10. You could reduce that to 4 over 5. We okay on those? All right, cool. Example 7. Use the diagram below to find the cosine of A. Okay, how are you going to find the length of the adjacent angle? Angle, that should say side. Hey, smart pants. Okay, Pythagorean theorem. I was hoping you guys would know that. Okay, we have a right angle. So if we need to solve for this side, then you can do Pythagorean theorem. I'm going to let you go ahead and do that. Okay, a squared plus b squared equals c squared. I'm so impressed.
I honestly did not remember that. I was dumb. I was like, I don't know. I'm not smart in the brain right
Okay, I'm getting that side B, which I labeled it B. If you label it something, that's fine. But that should be 24. That missing side should be 24. Yes? Okay. So now we want to do the cosine of angle A. So I'm going to mark angle A. Okay, cosine is what over what? Adjacent over hypotenuse. Which side is adjacent to angle A? Good, 24. And then over the hypotenuse of 26, we can reduce this, to 12 over 13. Now you're going to notice, I never write an answer as just 24 over 26 or 12 over 13. I note that cosine of A equals that. You have to do that, okay? Because there's a lot of different things that we could be talking about here. So make sure you always note which one you're talking about. Yes? Cool. We're doing okay? Okay. Okay, now example 8. Find the missing side length of the triangle below. Then find all of the trigonometric ratios for the triangle. This means you'll find sine, cosine, and tangent for angles A and angles B. We already know that angle C is 90 degrees. That one we don't have to worry about the trig for that one. Okay? So how are we going to find our missing side? Pythagorean theorem. Oh yeah, this one's not nice. Okay, so you'll notice right here it says leave your answer as a radical. Okay, so leave it as radical 96. Okay, don't put it in your calculator and get a decimal because that throws off our ratio.
What's radical?
The square root. Yeah. Do you want me to do the sine, cosine, and tangent with you?
No.
Good? Yeah?
Right, so would it just be the fraction like?
Well, let's do this. How about I do angle A and I'll let you do angle B.
Okay.
Okay. All right. So angle or sine of angle A. Okay. Angle A is right here. So sine is opposite over hypotenuse. What's opposite of angle A? What's hypotenuse? 10. So it'd be 2 over 10. Or you could reduce it to 1/5. Okay. Cosine of angle A. What side is adjacent to angle A? The square root of 96. Very good. Trust yourself, because you guys know what you're doing here. All right, over my hypotenuse, which we already said is 10. And then our tangent is opposite. What's opposite? 2 over adjacent square root of 96. Okay, now, when you do angle B, everything that was just adjacent, opposite, and hypotenuse is going to change because you're dealing with a different angle now. Okay, so now I go to angle B, 96, square root of 96 is opposite, 2 is adjacent. Okay, so see if you can get those here at the bottom. I'll give you an answer here in a second. on that? How'd we do? Yeah? We're doing okay? Good, okay. Go ahead and flip it over. That is practice. Okay, there's SOHCAHTOA at the top for you. If you flip it over, there's a couple extra questions, and then your solutions are on the bottom. Okay? So go ahead and work on those. See how you do. Make sure you check your answers as you go, because if you're having some issues, I'm going to help you troubleshoot.
These stay the same.
No, it depends on what angle. So if you're at angle A, this will be opposite. But if you're at angle B, this will be opposite.
Does the hypotenuse stay the same?
Hypotenuse will stay, but the only things that will change are the opposite.
So,
Those will flip.
so if it's opposite, it's not going to be the same one. So it's going to be this one.
That's easier.
That's easier because the hypotenuse is the same.
Right. And then B, this
This would be, so that would be opposite. Alright.
Yep.
And that would be adjacent.
Yes. Yep. Hello. I do. Sure. Should you bring your things or there's about 20 minutes left. Okay. Yeah, no problem. Uh-huh. Yeah, well, they need you just for, they have a quick thing to tell you to take a minute. Your locker?